Hello friends. Well, until now I had been involved with high-level language programming, and this is the first time I'm going to illustrate you a sample program on assembly level program as well. And for that reason I have basically made use of Intel 8085 toolkit. And here is a sum of two 8-bit number, and I will execute this whole entire program within my toolkit. So let me switch on the kit first. And here you can see 6 LED of 7 segment display. So let me explain what the sum of two 8-bit number is all about. Over here there are 3 columns. The first column represents the RAM that has been provided to me in this kit, and I will be using the starting address from F000. This is my mnemonic, and this mnemonic has got the opcode or the operation code. The color red signifies the data that will be provided. So the very first row represents a 2-byte instruction. As we all know that MVI A would take 1 byte, and that's the reason why it is occupying the memory location F000 with the opcode 3E, and 03 would be occupying another memory location, that is F001. Okay, so this is a 2-byte instruction. The same goes for the next instruction as well, where I'm supplying 05 to the memory location or the register B, and that would be occupying F002, and MVI B opcode is 06, and the data that will be represented to the register B would be 05, that will be taking 1 byte. Okay, now add B would be a single byte operation, and that's the reason it is only taking 1 memory location. And finally you have to transfer the data to the user defined memory location through the help of accumulator, and that's the reason why it is taking 3-byte instruction, where STA would be taking 1 memory location F005, D0 D5, this is the user address where the data will be stored finally, and we know that the least significant bit should be used first, and that's the reason 50 had been used in 1 memory location and DO had been used in another memory location, and finally the program comes to an end. So let's get started with the program. The first thing is I will reset, and then I'm going to set the memory location, and that is going to be F000, and here it is. Now at that given location I'm going to perform the operation code, that would be 3E. So let me provide the value 3E. Okay, so that's the value that has been provided over here. So that means the move immediate accumulator A representation or the register A representation has been done, and now we are going to perform the incrementation with the data that will be provided is 03. That's the data that has been provided. And next we increment for performing 06, that would be representing MVIB. So 06 would represent MVIB, and in the next memory location we are supposed to provide the data 05. So the data 05 has been provided, and finally we are going to perform the addition with the add operation. That's a 1-byte instruction, and that will be represented by the operation code 80. And now we are going to store the data that had been already generated through the help of accumulator. The accumulator representing 32. So let me store the data 32 over here. So 32 will be represented in the location F005, and now we are going to move to the next location where we will be sending the least significant bit first, that is 50, and then we will perform the high significant bit, that is DO. So it will be taking DO. So do remember, this is my location DO50, there where the summation had been stored. And finally we are at the last execution, and we will be going for the reset. That is the for that we will be performing the operation CF, and the program has been finally successful. So now we are going to execute the program, and in order to execute the program, first we will go for execute, and then we will go for the reset, and we already have gone for the reset, and now we go for the go, and then we will say the starting location. The starting location has been F000. So F000 that has been starting location, and then we'll go for the execute. So the program execution has successfully been done, and now we have to display the output, and that again we'll go for a reset, and then we will perform the set, and we have to provide the address. The address that has been provided over here is DO50. So let's provide the address DO50. DO50. So that's the address, and then I will provide the increment, and as we can see the output over here, that is sum of 3 and 5 is 8. So that's the result which you can see over here. So I believe this particular program gave you an idea of how an assembly level program has to be done with the help of Intel 8085 toolkit. And in my upcoming days I will be really working more on the ALP, because what I have realized that many upcoming students who would be the developers, they don't have much idea about ALP, and that's the reason why they tend to get themselves detached from programs, and that should not be the case after all. Okay, after all, if you're a computer science student, so you should have some affection towards programming, and for that reason ALP will be a very important thing to start with. Okay, so let's wait for my next video. Until then, have a nice time.